Good morning or afternoon, ladies, whenever you get to look at this. This little video is going to cover the three things that we did whilst you're away, and it was essentially three practical based things, so it's probably important that you get an idea of what we did. The first thing that we did on Tuesday was to look at exothermic and endothermic reactions. Now, a thermic reaction is one that involves heat, because that's where the word therm comes from. Exo means outside, as in exoskeleton. Endo means inside, as in an endoskeleton, which is the one that we have. So it's looking at whether or not heat is given out in an activity or a chemical reaction, or whether or not it is absorbed. So we see that by either increasing in temperature, which is an exothermic reaction, or decreasing in temperature with an endothermic reaction. Okay, so the first one we're going to have a look at is an exothermic reaction, which is magnesium and also zinc. Okay, so I'll place that in there, turn that on, and as you can see there, temperature starting to increase pretty sizably. Okay, so we started in the 40s, I think, and now we're already raised up to 56. So you can see there was a massive amount of heat that was given off. Okay, and I'll wait for a little while, but I think we've sort of made our point there, and that's only been 30 seconds, and it's probably increased nearly double from what it originally was. So if we were to stop that now, go back and have a look at the graph. Now they've changed all this, so that's my problem at the moment. They've changed it all, so there we go. So if we look at the minimum that it started off, so it started off at 46.7 and then went to 59.8 degrees Celsius. So that's a really large increase. Now, what I'll just make sure that I do here is I'll just make sure that I wash that down, because obviously what we don't want is cross-contamination. Okay. Now, in our second one, we're going to be adding some sodium acetate. Okay, so we're going to be adding some sodium acetate, and this time we're going to be seeing what happens with it. Okay, this time what we're going to do is add some water to it. Okay, so just drop a bit of water in there. Okay, drop it into our test tube there. So this is sodium acetate, and see we're starting off there at 21, and you can now start to see that it is in fact decreasing in temperature. So it started off as 21 and then working its way down. So that's a reaction that gets colder. Now we use this sort of reaction with those ice packs that when you crack and you break, they go colder. Okay, so what we're actually producing there is an endothermic reaction where it goes cooler. The other sort that we can do for an exothermic, for example, if you have something like hand warmers, and I know when I go skiing I put some hand warmers in, and they just release a little bit of heat because you crack them together, you mix the chemicals together, you produce heat. Now, in terms of the reason why, well, all simply has to do with chemical bonds. Okay, and the notes that I gave the students will be able to explain essentially what that is, because you can either break chemical bonds or you can produce chemical bonds, and how many you break or how many you produce is the reason why you get either heat being produced or it goes a little bit colder. So essentially exothermic reactions get hotter because the chemical bonds holding the atoms together break, releasing energy. So you break more bonds than you make. As a result, you release energy. Endothermic get cooler because the bonds between the atoms are absorbing energy. So if you make more bonds than you break, you end up with the reaction becoming cooler. So that's endothermic and exothermic. Okay, so and there's our reaction. That was our minimum temperature of 20. Now I can put that one away, because the next one we looked at related to corrosion. Now corrosion is a chemical reaction, and I got the students to set up 2 practicals on it. Okay, the first one, what we did was we got 3 test tubes, and in the first test tube we put a couple of tacks. Now in there what we did was we just put a little bit of water, so we didn't soak it, we just put a little bit of water in order to make the tacks wet. Okay, so you can see there, tacks inside wet. Then with the second one we did a couple of things. We put 2 tacks or nails, and these are simply normal nails. And then we put into that some boiled tap water, so water that's been through the kettle and has boiled off, and that will come to be very significant in a little while, in a little while's time. So we did that. Then what we did on top of that was we got some vegetable oil, just standard vegetable oil, and I got students to pour that down the side. Now hopefully on the video you'll be able to see it, but what essentially happens is it forms a layer on top of the water. Okay, so you can see there hopefully that you've got the oil here and you've got the water down there. Okay, so we did that one there. Then for the last group, simply got 2 nails, place them into a test tube, dry, and put a stopper on the top. Okay, and there'll be a prac write up that we do for that, and we simply left it. Okay, we set that up up on Thursday, and we simply left it, and we'll have a look at it on Monday. The second experiment we did was an interesting one, because it sort of scared people, but we used a substance called potassium ferric cyanide. Now cyanide's a gas that's poisonous, really poisonous. They tend to use it in the executions of people, but when we mix it with other substances it gains new properties. When it gains new properties, it has different properties, so this is actually not classified as a hazardous substance. Okay, and that's why you can see with the label there, it really doesn't have anything like danger on it, because it's really not. Now what they did was each group got 1 standard nail, and well actually 3 standard nails, and 1 of these galvanized nails. Now a galvanized nail is an iron nail that's treated with zinc, and that's to prevent rusting. Okay, so that's the purpose of that. What they did was they simply got 1 nail and put it into a standard test tube. Okay, the second nail they treated with Vaseline, so they covered it with Vaseline. Okay, and then put it into a test tube. The third nail they treated with nail polish, so they coated it with nail polish and put it into a test tube. And then the last one was just the galvanized nail. And then what they did to each of the test tubes is they put some of the potassium ferric cyanide in it. So this is one here, this is test tube number 1 I think. So that's the control, so it has no treatment. That one looks like it's Vaseline there. This one here looks it looks like it's the nail polish, and then this one here is the galvanized nail. Okay, and this experiment is around preventing rusting. So again, what will happen is the write-up will come up in a sec, and then we'll have a look at the results on Monday. So This one here is looking at the factors that cause rusting. This one here is looking at the factors that can help prevent rusting. Well, actually corrosion, sorry. Now, I've made a classic mistake that everybody makes. Rusting only occurs with iron. It's the only metal that rusts, all the rest corrode. Okay, so rusting is a form of corrosion. So in this one, we're looking at what causes it. In this one, we're looking at what is preventing it. If you get armed with this before you come to class on Monday, you will be essentially caught up on the stuff that you missed. Hope you had a lovely trip down to Manji. I used to live around Manjimup, not in it, but a couple of towns away. And yeah, pretty nice place. So thank you very much and have a nice day.